we'll see. We will see some operators. In those operators, how it is represented in classical notation, and the same operators, how it is represented in quantum notation, we will see. In general coordinates, what are the coordinates we have? In general coordinate is x, y, z. In classical, we will write as x, y, z, whereas in quantum, we will write in classical, we will write notation x, y, z. Whereas in quantum, we will write x bar, y bar, z bar. Whereas position coordinate, position is represented with r in classical mechanics. In quantum mechanics, position is represented with r with cap. Whereas in momentum is represented in classical mechanics as p. Whereas in quantum mechanics, momentum is represented with minus h dash lambda, where h dash equal to, we will represent h by 2 pi. Next, momentum components. What are the momentum components in general we have? The momentum components are P of X, P of Y, P of Z. This one is in classical. In quantum, we will represent momentum coordinates as minus I H dash dou by dou X, comma, minus I H dash dou by dou Y. ఇంకొక టర్మ్ మైనస్ I H dash dou by dou Z. ఇవి momentum coordinates. Velocity is represented with V, and velocity is represented with minus I H dash by M times of delta. Next, velocity components. Velocity components ఏమున్నాయి ఇక్కడ? Vx, Vy, Vz ఉంది. Momentum components and velocity components compare చేయడమా? Momentum components and velocity components. Momentum components మనకి ఏమున్నాయి? Px, Py, Pz ఉంటే, అదే క్వాంటమ్ లో మనం ఏం రాస్తున్నాం? మైనస్ I H dash dou by dou X రాస్తాం. If you come that with the same thing into velocity లోకి వస్తే ఏమవుతుంది? What is the difference between velocity and momentum? Momentum లోనేమో మనకు I H dash dou by dou X వస్తుంది. Velocity లోనేమో మైనస్ I H dash by M వస్తుంది. మైనస్ I H dash by M dou by dou X. ఇంకోటి మైనస్ I H dash by M dou by dou Y. ఇంకొక టర్మ్ ఏంది? మైనస్ I H dash by M times of dou by dou Z. అదే జనరల్ గా P లో ఏమొస్తుంది? మైనస్ I H dash ఒకటే వస్తుంది. మూమెంటం కి ఏమో మైనస్ I H dash ఒకటే వస్తుంది. వెలాసిటీకి వచ్చే వరకు మైనస్ I H dash by M times of dou by dou X. Next, minus I H dash by M times of dou by dou Y. ఇంకొక టర్మ్ ఏమొస్తుంది? మైనస్ I H dash by M times of dou by dou this. ఇవి velocity components. Next, energy. Energy is represented with E, and in classical mechanics లోనేమో ఎనర్జీని ఈగా రాస్తాము. క్వాంటమ్ ఆపరేటర్ లో ఎనర్జీని రాస్తాము I H dash dou by dou T. నెక్స్ట్ కైనెటిక్ ఎనర్జీ. కైనెటిక్ ఎనర్జీని ఇందులో T తో రిప్రజెంట్ చేస్తాము. ఇక్కడ క్వాంటంకి వచ్చే వరకు కైనెటిక్ ఎనర్జీని H dash square by 2m ఇక్కడ ఏం రాస్తాం? కైనెటిక్ ఎనర్జీని మైనస్ H dash square by 2m times of delta square. ఇప్పుడు ఇది ఎందులో? క్వాంటమ్ రాస్తాం. నెక్స్ట్ టాపిక్ మనకి ఏముంది? ఐగన్ వాల్యూస్ అండ్ ఐగన్ వెక్టర్స్. ఈ ఐగన్ వాల్యూస్ అండ్ ఐగన్ వెక్టర్స్ లో ఒక ఆపరేటర్ P ఉంది. ఒక ఆపరేటర్ P కి ఒక psi అనే వేవ్ ఫంక్షన్ అప్లై చేశాను. అప్పుడు మనకి ఏమొస్తుంది? న్యూ వేవ్ ఫంక్షన్ వస్తుంది. A operator P to this operator, I am applying a wave function psi. After applying the wave function, we will get new wave function as psi star. Psi star equal to momentum P times of psi. This is the first one. నెక్స్ట్ సెకండ్ ఆపరేటర్ ఏమొస్తుంది? ఆపరేటర్ P of xi equal to lambda of xi. P of xi equal to lambda of xi. This second eigenvalue function. Next third one. ఒక psi function కి దాన్ని కాంప్లెక్స్ కాంజుగేట్ ఫార్మ్ లో తీసుకుంటున్నాము. Suppose we have a function psi. I am taking its complex conjugate form. Then what will, after integrating, what we will get? Integral of minus infinity to plus infinity psi star అనేది మనకు ఫైనట్ ఉంటుంది. Psi అనేది ఒక కంటిన్యూస్ ఫంక్షన్ అయితే డో xi బై డో ఎక్స్ కూడా ఒక కంటిన్యూస్ ఫంక్షన్ అవుతుంది. Dou xi by dou x కూడా ఒక కంటిన్యూస్ ఫంక్షన్ అవుతుంది. సో again we will recall what are the things we discussed in eigenvalues and I. ఫస్ట్ ఏంటి? ఆపరేటర్ P అనే ఆపరేటర్ ఉంది మనకి. సో P అనే ఆపరేటర్ ఉన్నప్పుడు ఒక xi అనేది ఒక ఫంక్షన్. xi అనేది ఒక ఫంక్షన్. xi is ఒక ఫంక్షన్. P అనేది ఒక ఆపరేటర్. P అనేది ఏంది? ఒక ఆపరేటర్. P అనేది ఒక ఆపరేటర్ తీసుకున్నప్పుడు మనకు న్యూ ఫంక్షన్ xi స్టార్ ఈక్వల్ టు P of xi. ఇది ఫస్ట్ పాయింట్. నెక్స్ట్ సెకండ్ పాయింట్ ఏమొచ్చింది? సెకండ్ పాయింట్ ఏమొచ్చింది? P of xi ఈక్వల్ టు lambda of xi. నెక్స్ట్ థర్డ్ పాయింట్ ఏమొచ్చింది? థర్డ్ పాయింట్ మనం ఇంటిగ్రల్ ఫంక్షన్ తీసుకొని కాంప్లెక్స్ కాంజుగేట్ ఫామ్ లో రాస్తే xi స్టార్ అనేది ఒక కంటిన్యూస్ ఫంక్షన్. ఇది xi అండ్ i స్టార్ ఇస్ ఏ కంటిన్యూస్ ఫంక్షన్. ఫోర్త్ వన్ అనేది xi అనేది ఒక కంటిన్యూస్ ఫంక్షన్ అయితే డో xi కూడా మనకు ఒక కంటిన్యూస్. ఇప్పుడు xi అనేది ఒక కంటిన్యూస్ ఫంక్షన్ అయితే డో xi అనేది కూడా ఒక కంటిన్యూస్ ఫంక్షన్ అవుతుంది. These are the properties of eigenvalues and eigenequations. Next topic. ఇంకోటి సైమల్టేనియస్, అందులోనే ఐగన్ వాల్యూస్ అండ్ ఐగన్ ఫంక్షన్స్ లో మళ్ళీ ఇది కూడా రాయాలి. సైమల్టేనియస్ ఐగన్ ఫంక్షన్స్. సైమల్టేనియస్ ఐగన్ ఫంక్షన్స్ అంటే ఇప్పుడు 2 ఆపరేటర్స్ ఉన్నాయి. ఒక 2 ఆపరేటర్స్ ఏంటది? ఆల్ఫా అండ్ బీటా అనేది 2 ఆపరేటర్స్ ఒక వేవ్ ఫంక్షన్ xi of x మీద యాక్ట్ చేస్తున్నప్పుడు మనకు అప్పుడు ఏమొస్తుంది? ఆల్ఫా ఆఫ్ xi of x ఈక్వల్ టు lambda 1 of xi of x. ఇంకోటి beta times of psi of x equal to lambda 2 times of psi of x. అక్కడ lambda 1 lambda 2 ఏంటి? ఇవి రెండు 2 ఐగన్ వాల్యూస్. అండ్ psi of x అనేది ఏంటి? ఐగన్ ఫంక్షన్. ఐగన్ ఫంక్షన్. సో 2 ఆపరేటర్స్ ఆల్ఫా బీటా ఉన్నప్పుడు ఆల్ఫా ఆఫ్ psi of x equal to lambda 1 of psi of x, beta of psi of x equal to lambda 2 of psi of x. This is simultaneous 2 eigen functions తీసుకున్నప్పుడు. Next topic is Okay, next one is hmm, independent, time independent, eigenvalue and eigenfunction. Next, significance of wave functions. The significance of wave function last year question paper lo 10 marks question వచ్చింది. Significance of wave function is in the last year question paper. It is a 10 marks question. Hmm. Again, this significance of wave function is categorized into three. One is Millikan's interpretation. What is the first one? First one is Millikan's interpretation. According to Millikan, a wave function psi is a mathematical function and it is introduced to explain electron diffraction experiment, which is invented by J.P. Thomson, and calculation of intensity of waves scattered by a crystal. అంటే ఏంటంటే ఇక్కడ ఈ మిలికాన్స్ అనేటైనా ఒక వేవ్ ఫంక్షన్ psi అనే ఒక వేవ్ ఫంక్షన్ is introduced to simplify mathematical expressions. Like for few experiments, like electron diffraction experiment, which is introduced by J.B. Thomson, and calculation of intensity microwave scattered by crystal in the diffraction of the detector. But what is the disadvantage of this one? Without knowing the significance of the operator, we cannot use. Suppose we are using any operator, we have to know its significance and we have to know its mathematical functioning, mathematical quantity. So without mathematical significance, it is difficult to use the function psi. That is the Millikan's interpretation. Next, we will go for the next interpretation. So what is understood by Millikan interpretation? In Millikan, according to Millikan wave function, psi అనేది ఒక ordinary wave function. It is used to perform a computations. What are the computations? Like electron diffraction experiment, which is done by J.P. Thomson, as well as for the interpretation of the waves scattered by the crystal in the direction of the detector. But without knowing the significance of the mathematical quantity, it is difficult to use. This is about Millikan's interpretation. What is the next one? Next one is the Schrodinger interpretation. The Schrodinger interpretation, the photon density is directly proportional to A square. A is the amplitude of the wave. Here I am taking A as A is taken as the amplitude of the wave. If A is the amplitude of the wave, then density is directly proportional to the square of the amplitude. Density is directly proportional to the square of the amplitude. So here photon density. What is photon density is equal to energy per unit volume by energy of one photon. Energy per unit volume is amplitude square by energy of the one photon is represented with h nu. So total density. So here I am writing total density. Total density is the amplitude square by h nu. This h nu is the energy of the photon. A is amplitude. A is amplitude of the photon. So suppose psi is the amplitude of the any matter wave in the space, then the particle density is proportional to this absolute value. And we are also representing with its psi square. What is xi square? Xi square is the proportional to the number of particles crossing a unit area per second. Here xi square is number of particles crossing per unit area per 1 second, which is explained with the particle density. So here in Schrodinger interpretation, what are the things you have to cover? In Schrodinger equation, suppose if A is the amplitude, A is the amplitude. Here the function psi explains about the concept of charge density. Xi explain about what? Charge density. Then the energy permission, energy per number of photons emit or photo density is equal to A square by h nu, where A is the amplitude, h is Planck's constant, nu is the frequency. And here we can also measure xi square also. We can also xi square. So this xi square is directly proportional to density. This xi square is directly proportional to density. And the xi is also referred to the single particle. We are representing this xi for the single particle. This is about Schrodinger interpretation. Next, we have Bohr interpretation. What is Bohr said? Whatever Schrodinger interpreted, that is elaborated and explained more clearly by who? Max Born. Giving a new idea. Whatever Schrodinger is discussed, the same discussion is elaborated by Born as well as by Heisenberg, as well as Born and Dirac. So Schrodinger wave interpretation, whatever is did, they are elaborated. Who are elaborated here? One is Dirac is elaborated. Max Born is elaborated. Next, Heisenberg is elaborated. Heisenberg elaborated. All these people are elaborated whatever Schrodinger is interpreted. Here, suppose I am taking a xi square is a real value function of the particle. A particle with a real value function with its volume. What is volume? With the volume is dx, dy, dz are the volume. Then we can write as triple integral of xi square of dx, dy, dz. We will recall once again what is Milliman's, what is Schrodinger interpretation, what is Born interpretation. We will recall once again. And this Millicon interpretation, one is a function xi and a function తీసుకున్నాను. I am taking a function, mathematical function di. This function is used for the experimental results of electronic diffraction experiment, which is explained by J.P. Thomson. But without knowing the significance of the function, it is difficult to use. That is the Millikan's interpretation. And next, what we have? Next is Schrodinger interpretation. In Schrodinger interpretation, the photon density is directly proportional to A square by h nu, where A is the energy, where A is the amplitude, and h nu is the energy of the photon, and this photon density is directly proportional to A square. Suppose I am taking a function psi. This is proportional to the particle density, and this psi is also useful for the single particle. Next, come to boron interpretation. Now, what the things we are studying in boron interpretation? What we are studying in boron interpretation? Whatever the Schrodinger interpretation is taken, this boron, Dirac, Heisenberg, they are elaborating the thoughts of the Schrodinger equation. They are elaborating Schrodinger equation and taking xi square as a function, real value function. Xi square is a real value function with its volume. What are the volume? Dx, dy, dz is the volume of the function. Then we can write as triple integral of psi square times of dx, dy, dz. This is about boron interpretation. So we completed Schrodinger సమీకరణ సిద్ధాంతము. ఈ Schrodinger సమీకరణ సిద్ధాంతంలో మనం ఏమేమి డిస్కస్ చేస్తాం? Schrodinger వేవ్ ఈక్వేషన్ లో టైం డిపెండెంట్ వేవ్ ఈక్వేషన్ కంప్లీట్ చేస్తాం, టైం ఇండిపెండెంట్ వేవ్ ఈక్వేషన్ కంప్లీట్ చేస్తాం. అండ్ నెక్స్ట్ ఆపరేటర్స్ ని క్లాసికల్ లో ఎలా రిప్రజెంట్ చేయాలి, ద సేమ్ ఆపరేటర్స్ ని క్వాంటమ్ లో ఎలా రిప్రజెంట్ చేయాలో చూస్తాము. నెక్స్ట్ ఐగన్ వాల్యూ అండ్ ఐగన్ ఈక్వేషన్స్ ఇస్ కంప్లీటెడ్. Next, the significance of wave function is completed. In the significance of wave function is a 10 marks question. Significance of wave function is expected 10 marks question from previous year question papers. Next, next 5th unit kodamu. Next, in the 5th unit lo manaku emundi particle in a box. Next, we will discuss 5th unit. 5th unit lo manaku 2 topics unnayi. మెయిన్ ఇంపార్టెంట్ టాపిక్స్ 2 ఉన్నాయి. ఒకటి పార్టికల్ ఇన్ ఏ బాక్స్ ఇస్ ఇంపార్టెంట్ టాపిక్, ఇంకొక టాపిక్ పొటెన్షియల్ వేరియన్స్. కానీ మనం మోస్ట్ ప్రియారిటీ దేనికి ఇద్దాము? పార్టికల్ ఇన్ ఏ బాక్స్ కంపేర్ టు పొటెన్షియల్ బ్యారియర్. We can neglect this one for examination point of view, and we will study which is a particle in a box today. We will see the derivation part of particle in a box. Next topic we are seeing is from unit 5, particle in a box. Next our topic is particle in a box. Next we will see particle in a box. Suppose diagram. We have particle in a box. Here the velocity of the particle inside the box is v of x equal to 0. Outside the box, velocity v of x equal to infinity. Here also we have v of x equal to infinity outside the box. And potential p of x, the potential energy p of x equal to 0. Here the p of x equal to 0. Inside we have potential energy maximum. So this is the energy. Also another energy in. For this, we will see the description. What is V? V is the potential energy of the particle. V is the potential energy particle. And the potential energy is infinite at both the sides of the box. Potential energy is infinite both sides of the box. Potential energy is infinite at both sides of the box. And potential energy equal to V of X equal to 0. Ekkada inside the box. This is inside the box. Okay. Now we will take the wave function. The wave function psi equal to 0 for x is lesser than equal to 0 and x is greater than or equal to L, which implies psi of x is arranged 0 actually. For x is lesser than or equal to 0, comma x is greater than or equal to A. Next, psi of x is not equal to 0 for 0 less than x less than A. Less than A. Next, the Schrodinger wave equation, what we have? The Schrodinger wave equation is, what we have Schrodinger wave equation? The Schrodinger wave equation is minus h dash square by 2m times of rho square x by 2x square is equals to E of psi. This is what? This is Schrodinger wave equation. Next, I am multiplying both sides by minus 2m by h dash square on LHS and RHS side. Multiply minus 2m by h dash square on LHS and RHS side. After multiplying it across LHS and RHS side, after multiplying LHS and RHS side, we will get minus h dash square by 2m times of minus 2m by h dash square times of rho square psi by dou x square is equals to RHS we have E psi minus 2m by h dash square times of E of psi times of E of psi. So this term will get cancelled and this 2m is cancelled. So what we will get? Minus minus we will get plus sign. And so LHS term we will get rho square LHS side I will get rho square psi by dou x square plus 2m by h dash square times of e of psi equal to 0. From this, dou square psi by dou x square plus 2m plus 2m by h dash square of psi equal to 0. Consider 2me by h dash square equal to alpha. Consider 2m by h dash square alpha. Step is not alpha, alpha square. Then dou square psi by dou x square plus alpha square of psi equal to 0. This is the one of the important equation we got. This alpha square equal to 2me by h dash square is equation number 1. Next, dou square x psi by dou x square of r square psi is equation number 2. Now, after this, I am taking a general equation and simplifying this general equation. I'm writing from this side. The general solution of the equation is the general solution of the equation I am taking as psi equal to a sin alpha x plus b cos ax. It's taken as a sin alpha x plus b cos ax. Here I'm taking b term is completely the boundary conditions. First, what is first boundary condition? The first boundary condition. What is the first boundary condition? The first boundary condition is psi equal to 0 and x equal to 0. Then I will take 0 as taking only b, considering only b term, b of cos 0, which implies cos 0, 1, we will get b value as 0. Substitute this b value equal to 0. Substitute b equals 0 in b is equal to 0 in general equation. Then we will get y equal to a sin a sin ax. Sorry, this is a sin ax. Then we will get a sin ax. B equal to 0. Substituting b equal to 0. Then we will get psi equal to a sin ax. Now Apply second boundary conditions. We apply second boundary conditions. Xi equal to 0, x equal to L. Xi equal to 0, x equal to L. And that is Xi equal to 0, x equal to L. Then we will get 0 equal to main equation, general main equation lo substitute cheyali indulo. Substitute in this equation. Then we will get 0 equal to A times of sin AL. Which since A అనేది not equal to 0. If A అనేది not equal to 0 means AL ఏమవుతుంది? AL equal to n pi అవుతుంది. From this A equal to n pi by L. A equal to n pi by L. So substituting in this equation, I am substituting this A value. This A value I am substituting in this equation. This A value I am substituting in this equation. After substituting A value, what we will get? Function. What is the function? Sin of x equal to 2. A as it is I am writing sin as it is. In place of A, I am substituting n pi by L. N pi by L times of x. In this n pi by L, I am treating as alpha. This n pi by L I am treating as alpha. If n pi by L is treating as alpha, then what we will get? Alpha square equal to n square pi square by n square. Got alpha square వచ్చేసింది. నాకు మనకు ప్రీవియస్ కూడా ఒక ఆల్ఫా వచ్చింది. ఎక్కడ వచ్చింది ప్రీవియస్ ఆల్ఫా స్క్వేర్? 2 ఆల్ఫా స్క్వేర్స్ ని we have to equate. What is the equation 1 లో ఆల్ఫా స్క్వేర్ మనకి ఏమొచ్చింది? 2me by h dash స్క్వేర్ వచ్చింది. ఇక్కడ ఆల్ఫా ఏమొచ్చింది? ఆల్ఫా స్క్వేర్ ఏమొచ్చింది? n pi square by n square. Equate 2 alpha squares. Next what we have to equate 2 alpha squares. Alpha square, then 2 alpha squares ni equate cheyali. Alpha square equal to alpha square. First alpha square మనకి ఏమొచ్చింది ఇక్కడ? 2me by h dash square వచ్చింది స్టార్టింగ్ లో. 2me by h dash square వచ్చింది. సెకండ్ టైం ఆల్ఫా స్క్వేర్ ఏమొచ్చింది? n square pi square by L square వచ్చింది. ఇప్పుడు దీని నుంచి ఎనర్జీ ఈక్వేషన్ E, రైట్? ఎనర్జీ ఈక్వేషన్ E. ఎనర్జీ ఈక్వేషన్ E ఈక్వల్ టు n square pi square h dash square by 2m L square. In this, if h dash equal to h by 2 pi, imagine if h dash equal to h by 2 pi. Then what happens? If h dash equal to h by 2 pi, then substitute that value n square pi square by 2 times of n square. Energy E equal to, in place of h dash square, I am substituting h square by 4 pi square. This pi square is cancelled. So what we will get answer? Energy E equal to n h square by 8 m n square. This is the answer for energy of equation in a particle in a box. This is the energy equation for the particle in a box. Still continuation we have. To this energy equation అయిపోయినాక మనం ఏం రాయాలంటే నార్మలైజ్డ్ ఫంక్షన్ రాయాలి. వేవ్ ఫంక్షన్ ఫర్ స్టేషనరీ స్టేట్ లో ఎలా ఉంది then probabilities. So still now what we calculated? Again, I will repeat whatever we calculated. Particle in a box key. Inside the box, outside the box. Inside the box, potential energy infinite ఉంటుంది. Outside the box, potential energy zero ఉంటుంది. Inside the box, velocity is zero. Outside the box, velocity is infinite. Here V అనేది potential energy. Potential energy inside the box అనేది zero ఉంది మరి. Next, what we did? ఒక వేవ్ ఫంక్షన్ xi అనేది తీసుకుంటున్నాను. దిస్ వేవ్ ఫంక్షన్ ఈస్ x is 0 ఉంటుంది. ఎక్కడ x is lesser than or equal to 0, x is greater than, అంటే this is 0 here. This is from 0 to L మధ్యలో ఈ వేవ్ ఫంక్షన్ ఇక్కడ 0 ఉంటుంది, ఇక్కడ 0 ఉంటుంది. ఇది వేవ్ ఫంక్షన్ కదా. Here the wave function xi of x equal to 0. Ekkada when x is lesser than or equal to 0. Again this side, even this side, the wave function xi of x equal to 0. But in this case, in this inside the wave function xi of x is inside the box, wave function xi of x is not equal to 0, where x lies between 0 to a. అంటే లెంత్ a ని ఇక్కడ a అనుకుంటున్నాం. అయిపోయాక షార్డింజర్ వేవ్ ఈక్వేషన్ రాయాలి. షార్డింజర్ వేవ్ ఈక్వేషన్ రాసి అందులో నుంచి ఒక ఈక్వేషన్ తీసుకొచ్చాను. డో స్క్వేర్ సై బై డో ఎక్స్ స్క్వేర్ టైమ్స్ ఆఫ్ ఆల్ఫా స్క్వేర్ ఆఫ్ సై ఈక్వల్ టు 0. నెక్స్ట్ బౌండరీ కండిషన్స్ యూజ్ చేసి ఆల్ఫా ఈక్వల్ టు ఎన్ పై బై ఎల్ అని ప్రూవ్ చేశాను. మేకింగ్ టూ ఆల్ఫాస్ ఆర్ ఈక్వేటింగ్ చేసి ఎనర్జీ ఈక్వేషన్ క్యాలిక్యులేటెడ్. After calculating energy equation, wave function for stationary state రాయాలి. After calculating energy equation, wave function for stationary state. Wave function for stationary state ఎట్లుంటది మనకు? Wave function for stationary state initially E graphs. This is for psi1 where n equal to 1 only. Next wave function for second state psi2. This is psi2 only where n equal to 2 only. Next psi3 లో ఏముంది? First pulse, second pulse, third pulse. This is for n equal to 3. This is represented with psi3. For the same thing, probability, what is the probability distribution for this one? The same thing, wave function for stationary state. మనం stationary state కి రాసాము. Next probability distribution. Probability distribution. The probability distribution we have first. Next probability distribution square లో రిప్రజెంట్ చేస్తాం. psi1 square, psi2 square, psi3 square. After this we have to write normalized function. ఇదంతా పార్టికల్ అనే బాక్స్ లోనే వస్తుంది టాపిక్. నెక్స్ట్ ఇస్ నార్మలైజ్డ్ వేవ్ ఫంక్షన్ క్యాలిక్యులేట్ చేయాలి. వాట్ ఈస్ నార్మలైజ్డ్ వేవ్ ఫంక్షన్? This Normalized wave function. For the normalized wave function, integral 0 to L, psi star sin dx equal to 1. Next, integral 0 to L a square sin square n by x by L equal to 1. After integrating, we will get a square times of L by 2 equal to 1. If a square times of L by 2 equal to 1, we will get a square equal to 2 by L. Then we will get a equal to under root of 2 by L. So getting a equal to under root of 2 by L. Then normalized the wave equation. Then normalized wave equation we have to write. Then normalized wave equation is in place of a substitute that one, we will get psi of n equal to 2 by L under root times of sin n by x by L. Here, conditions, psi is either positive or negative value, first condition. Next, second condition is psi is either positive value or negative value. Next condition is psi square is all, but psi square is always positive only. Next, probability is always 0 at boundary condition. Next point is the probability always is always 0. At boundary conditions. We will see once again what we discussed. After calculating energy value, I wrote wave function for stationary state as well as probability distribution. The first image is the wave function for stationary state. The second one is the probability distribution function. The probability distribution function is represented xi1 square, xi2 square, xi3 square. Where stationary state is xi1, xi2 and xi3. After this, the normalized wave function. The normalized wave function is integral 0 to L psi xi star dx equal to 1. That is written as integral 0 to L a square sin square n pi x by L equal to 1. Make it integration. After integration, we will get a square times of L by 2 equal to 1. From this, calculated the value of A. We got A equal to under root of 2 by L. Then the normalized wave equation of n equal to under root of 2 by L Sine of n by x by n. Here we have rules. Psi is either positive value or negative value, but psi square is always positive value only. And across the boundary conditions, probability is always zero at the boundary conditions. Now we will see from the textbook. Topics we will see up to where we completed in derivation parts. Just we will recall once again what we discussed. Applications of Schrodinger wave equation is completed today. Taking general condition and up to normalized equation is, see, this is the particle wave in a one box. Particle wave in a box. Already diagram is written there. What is this diagram represents? I wrote this time, but then reverse the diagram. Inside what we have V of x. Inside what is the? Inside we took inside V of x equal to 0. This is potential barrier. Next topic is potential barrier. In particle in a box, we took V of x equal to 0 inside, outside V of x equal to infinity. Here also V of x equal to infinity. This topic is for which one? Particle in a box. Next, what is this one? Potential barrier. Just a diagram representation we will discuss. No need of in-depth definition. Here, reverse diagram. Outside V of x equals 0. Outside V of x equals 0. Inside V of x equal to infinity. Infinity, or we can represent V of x equal to V naught. Same way alpha square is calculated. And here we are taking two xi1 equations. What is the first xi1 equation? Just for reference, what is the first xi1 equation? Dou square xi1 by dou x square plus alpha square of xi1 equal to 0. Next equation is dou square xi2 by dou x square plus 2m by h dash square of e minus v of xi2 equal to 0. After simplifying this one, we will get potential barrier answer, but perfectly prepare particle in a box question only. See what are the potential barrier question is asked. Next here, potential barrier. What is eigenvalue? Particle in a box. Here this one is particle in a box in x direction. Particle in a box in which direction? In x direction. Particle in a box in x direction. So still now in block 1 we completed unit 1 as well as unit 2. In block 2 unit 3 is completed, unit 4 is completed, unit 5 is completed. In unit 5 only one topic we discussed in exam point of view, particle in a box. So still now we completed 2 units. In the next class, we will see block 3 and block 4. What are the topics we have in next blocks? this block 1 Bode's theory and line spectra is completed. Quantum numbers completed. Photoelectric effect and matter waves completed. Schrodinger wave equation completed. Applications of Schrodinger wave equation. In this application of Schrodinger wave equation, we completed particle in a box in X direction. Which direction? In X direction is completed. Still we have to discuss block 3 and block 4. In block 3, how many units? 1, 2, 3, 4 units. In the block 4, 3 units. 1, 2, 3. Total 7 units we have to discuss in the next coming classes.